Good morning, everyone. My name is Rohan Bhatia, and I'm a product manager at AWS. Today, I'm excited to talk to you about Amazon Aurora global databases and how you can get started. In today's session, we'll go through an overview of global databases. How do they work, and what are the key use cases? Next, we'll see how you can use global databases along with an RDS proxy. Finally, we'll conclude with a demo. But before we dive into global databases, let's talk about what is Amazon Aurora. Amazon Aurora is a fully managed, highly available database service designed to operate in the cloud. It is MySQL and PostgreSQL compatible and offers you the same performance that you would expect out of a commercial database at just 1/10 the price. It is also the fastest growing service in the history of AWS. Aurora Global Databases are a feature of Amazon Aurora that allow you to truly build global application that spans multiple regions. Global databases do this by replicating data from a primary region across multiple other regions, with replication lag that's typically under a second. Using global databases, you can also recover from a disaster situation in typically under a minute. And in the next slide, we'll see how global databases work together to provide you these benefits with negligible performance impact on your database. One of the key innovations for Amazon Aurora is that it separates the compute and the storage layer such that both can scale independently. Global databases build on top of this innovation. By having replication servers on either side of the primary and second region, global databases replicate data directly from the storage layer. This way, we can ensure that the replication does not have a performance impact on the primary instances in your clusters. Now, I want to dive into 3 key use cases, starting with disaster recovery. When it comes to disaster recovery across regions, you could avail from one of 3 options. You could either create a snapshot copy of your data across regions. However, in case of a disaster, you would have to restore the snapshot, hydrate the storage volumes, and provision capacity. All of these steps would increase your recovery time objective. Another option is that you could set up logical replication from your primary database instance to other database instances across regions. However, with logical replication, especially in cases of high throughput, you could end up impacting the performance of your primary database instances. You would also be responsible for setting up and managing logical replication across regions and across multiple instances. Global databases, on the other hand, offer you a fully managed experience to replicate data across regions. It gives you an automated mechanism to fail over across regions and recover from disaster in typically under a minute. To help meet your recovery time as well as cost needs, global databases allow one of 3 provisioning strategies. You could either provision the same capacity that you would keep in a primary cluster and the same capacity in the secondary cluster. This way, you can have the same capacity that you would have from the primary cluster and recover quickly from a disaster. You could also provision the secondary regions with serverless V2 nodes, such that you only pay for the compute that you actually need. And lastly, because the storage and compute are decoupled, you could run the secondary clusters without any database instances, thereby saving on compute costs. Now let's dive into one of the 2 mechanisms that global database offer for recovering from disaster, starting with managed planned failover. With managed planned failover, global databases take care of automatically switching from one region to another without any data loss. This can be useful for you to test your disaster recovery setup, which many a times is required to meet compliance needs. Now let's see how this works in action. When you start the managed plan failover, global database stops the writes in the primary region and waits for the secondary region to catch up. After that, it cuts the replication and switches the direction. This way, it can give you an automated way to fail over from one region to another while maintaining your global database topology. Now, sometimes it is not possible to switch from one region to another, such as in the event of a regional outage. Global databases also give you the functionality to detach and promote a secondary region to a standalone primary region in typically under 1 minute. You can also avail a feature known as Manage Recovery Point Objective to specify a desired window of your database recovery. With Managed RPO, Global Database can stop the writes on the primary region to ensure that your secondary, at least one of your secondary region, remains within the desired window of data recovery. Now, the next use case I want to talk to you about is scaling low latency global reads. Each of the global database can span up into 5 secondary regions, each of which can have up to 16 read replicas, with replication lag happening across regions with typically under a second. This way, you can truly build global applications that read data locally and provide a more responsive experience for your customers. And the last use case that I want to talk to you about is building global applications that also occasionally send writes from across regions. Using global database, write forwarding, you can forward the writes from the same endpoint that you would use to connect for your reads in secondary regions. Write forwarding also offers 3 different types of consistency guarantees so that you can forward the reads and writes from a secondary region without worrying about read after write consistency issues. Using write forwarding, you can save on the headache of building your own complex logic to manage writes from across multiple regions. Global Database also works with a breadth of features supported on RDS and Amazon Aurora, including Amazon RDS Proxy. RDS Proxy is a fully managed, highly available database proxy that works with RDS MySQL, RDS PostgreSQL, MariaDB, SQL Server, and Amazon Aurora. RDS Proxy provides you 3 key benefits. First, it can help scale your applications by pooling and sharing database connections. This way, you can open tens of thousands of connections from your application to the proxy, which in turn more efficiently manages connections to your database. By more efficiently managing connections to your database, proxy can help reduce the stress on your database memory and compute resources. Another advantage of using RDS Proxy is that it can help improve your application availability by providing more seamless and up to 66% faster in-region failovers. Lastly, RDS Proxy is integrated with AWS Secrets Manager and Identity and Access Management Service. Using RDS Proxy, you can enforce IAM authentication for your applications such that eliminating the need for storing plain text credentials in your application code or configuration files. Now, you can avail the same benefits that I talked about for RDS Proxy in any of the global database primary regions. Additionally, by having proxy in the second region, you can speed up recovery time and queue requests during cross-region failovers. You can also use RDS Proxy to scale the reads in the secondary region or improve security by enforcing IAM authentication in both the primary and secondary regions. Now let's see all of this in action via a demo. So today I'm going to create start by creating an Amazon Aurora database in the North Virginia region. For today, I'm choosing a MySQL compatible database, but you could also do this with PostgreSQL compatibility. You can look at the versions that are supported on global database. And then let's give a unique name to our database cluster identifier. We also support one-click integration to create RDS proxy. Let's enable that for now. And then let's create a database. Now that our database is ready, let's see how we can attach an AWS region to promote this database into a global database. First, you choose an identifier that would be your parent cluster ID under which your remaining clusters would reside. Choosing US East Ohio, but you could choose from a host of other regions supported by global database. And then I'm also enabling write forwarding. Now that our cluster is ready, you can see that you have a primary cluster underneath this parent cluster, as well as a secondary. The primary has a reader and a writer instance, and the secondary has a reader instance. Now let's navigate to the secondary cluster and just see how the endpoints and the topology looks like. You can see that there is a writer instance endpoint and a reader instance endpoint. And since we don't have any proxies in this region, let's go ahead and create one. Start by giving a unique identifier for the proxy. And I'll choose the same engine family as the database, which is MySQL and MariaDB. Let's find the cluster that we want to attach to. And then I'm using a pre-built secret, but you could also create one on the console. And keeping all the other settings the same, let's go ahead and create the proxy. Okay, now let's recap the topology. We have a secondary cluster with 2 instance endpoints, and we have a proxy with 2 endpoints, both for a read-write and read-only operations. Let's navigate to the primary cluster, which will also have a read-write endpoint and a read-only endpoint for your applications to connect to, as well as a proxy, which would also come with the same read-only and read-write endpoints. Now, first thing I want to show you is an unplanned failover and how recovery time looks like with the proxy. First, let's remove the database from your global database cluster. Now, I have built a simple Python script that would try to connect to the database and report on the first time that it is able to do so. As you can see, with proxy, you were able to detect a failover within 3 seconds. And when the failover actually completed, the results were returned in just 16 seconds after the failover. The next use case I want to talk to you about is scaling global reads with RDS proxy. Let's navigate to the secondary region. And I'm going to use the same proxy with the read-only endpoint. Now, this global database secondary region has 3 replicas. And to load test, I'm using a Lambda function that will open up to 10 connections each time it is invoked. We'll monitor the status using a CloudWatch metric that shows the database connections as well as the proxy load. And I'm using an open source tool to load test, which will fire a bunch of Lambda connections. As you can see, the open source tool Artillery is already created around 12 connections per second, which means around 120 connections. As you can see that there's an exponential increase in the connections to the database proxy, which is the blue line. And proxy is internally balancing the load across each database instance, meanwhile sharing the connections and reducing the number of connections to your database instance. Now that concludes our demo. So in today's session, you learned about how you can get started with global databases and use them along with an RDS proxy. I am very eager to see how you will use these 2 features for your upcoming application development. Thank you.